Hey guys, welcome back. So today I'm just going to go over the review that I posted for the Chapter 5 test. So this way, if hopefully you do the review, you could check your answers on the answer key that I will have posted. And then if there's anything that you still are having trouble with or you're not quite sure where the answer came from or whatnot, then you can check this video and see how you do the problem. Okay, so the first couple problems here are on X and Y varying inversely. So just as a little refresher, the inverse variation equation is Y equals K over X, which means if you're just trying to get K, you would multiply both sides by X, right? So then to get K, you're just doing X times Y. So if you remember back from our notes, which of course you can reference when you're taking your test on this, you are going to basically do 3 steps. So part A, you're going to have to first find K. So the first thing you're going to do is have to find that K. Then the second thing you're going to do is you're going to write the equation. So if you remember, that's just substituting in that value that you get for K, but leaving the X and Y as variables. And then thirdly, you'll do the second part of the equation here, which is the then find Y when X equals -2. So that's when you do that solving portion, okay? But a lot of times people will try to skip one and go to the end. So when you're taking the test, you gotta be careful because sometimes it asks you for the equation, sometimes it'll ask you for the solution. So you have to make sure you're not skipping all the way to the end. Okay, so for number 1, the first thing we want to do is find K. And to do that for inverse variation, you're just gonna multiply the X and the Y. So to find my K here, I'm just going to multiply 2/3 times -24. And I can just kind of simplify this by cross-canceling a little bit, and then I end up with -16. Now I'm not done because I need to write the equation. It says use the given values to write an equation relating X and Y. So that's that inverse variation equation. So Y equals, and then I put in that -16 that I just got for K over X. So that's what the equation looks like. So don't forget that. And then the second part of the problem, so I'm going to call this part B here, is when you do this third step where it says then find Y when X equals -2, and you substitute in that -2. Now what happens is a lot of people do these problems and they find the K, and then right away they put Y equals -16 over -2 and solve it. They don't ever actually write that equation that I boxed out here for you. So if you do that, then you might lose credit for not having that part done. Okay, so for number 2, same procedure here. So first we're going to find the K by multiplying the X and the Y together. And we're multiplying 2 fractions. We just multiply the numerators and then multiply the denominators. Now this one looks a little funny because it's a fraction. So when we go to write the equation, we have Y equals 8 over 25 over X, and that kind of looks a little bit weird, right? So if you think about it, if you were doing 8 over 25 divided by X, you're really multiplying it by 1 over X. So that's just going to be 8 over 25X. So it'll look like that. That's what the equation would look like. And then the third part is you're going to substitute that -2 in for the X and then actually solve for Y. So 25 times -2 would give me -50, and then that answer can be simplified to -4 over 25. Now, the next 2 questions are asking us to determine whether or not the data tables show direct variation, inverse variation, or neither. So we just went over the inverse variation, and inverse variation is when the K is the same, or that's a constant when you multiply the X's and the Y's. But if you remember from our notes, direct variation is when you get the K or the constant by dividing the y's by the x's. So we want to see which one of those gives us the same value, which would mean it's a constant. If it doesn't work for either, then we would say it's neither. So the first thing I'm going to do is try for direct. So if I'm going to try to see if this is direct, I'm going to divide my y's by my x's and see if that gives me a constant value. So negative 12 divided by 3 equals negative 4. 9 divided by negative 4 equals negative 2.25. So clearly it's not direct because we're getting two different answers already. So then if I want to try the inverse, to get my constant, I would need to multiply my x's and my y's together. So if I do 3 times negative 12, I get negative 36. Negative 4 times 9 is also negative 36, and then negative 7.2 times 5 is also negative 36. So this one works. So we know it's inverse variation. The k value is negative 36. So when I go to write my equation, because it says write the equation if the table is one or the other, so it's y equals k, which is negative 36, over x. So that's how we would write that inverse variation equation. Now when we go to number 4, I'm going to try it again. So if I'm going to try for direct, that would be finding my constant by doing y divided by x. So 3 over 12 simplifies to 1/4. 6 over 24 also simplifies to 1/4. Negative 2 over negative 8 also simplifies to 1/4. So we know it's direct, and the k value is 1/4. So when we write the equation as direct variation, it's just k times x. So it's going to be 1/4 times x, and that's how we would write that equation. Now, if you had checked inverse first, just to kind of see what that would have looked like, that's when you get your k by doing x times y. You would have had 36, 6 times 24, which is not 36, and then here we would have had 16. So I think this one would have been 144. All right, so obviously it was not inverse because we multiplied all those x and y's. We got totally different answers every time, so there's nothing constant about that. Okay, so then the next thing from that first section that we did in chapter 5 is on the joint variation. So the joint variation is just a little bit more complex version of the direct variation because there's more than just one thing being multiplied to that constant. So if we remember our equation for joint variation, again, you can look this up in your notes. It was z equals k times x, y. And if we were getting our k, we would just take that z and divide it by that product of x, y. That was like the shortcut to get the k. So again, we're going to find the k first. Then we're going to write the equation. And then the third thing we'll do is we'll solve for the z given these two x's and y's here. So for number 5, the first thing we're going to do is find the k by taking the z value and dividing it by the product we get from x times y. So 2 over negative 48, which simplifies to negative 1 over 24. Then we write our equation. So z equals, we substitute in the k we just got, and then just multiply it to an x and a y. Then number 3, you're going to substitute in this x and y that's given to you in the instructions, and you're going to solve for z for this situation. So this equation is important because it would work for any x and y. You just plug them into that equation, but you want to have the equation that's going to be used for all the different points. So if I go to solve this, negative 1 over 24 times 6 times negative 4. Well, 6 times negative 4 is negative 24, and they're going to all cancel out. So you're going to end up with just a z equals 1. So now when we go to do number 6, first thing we're going to do is find our k by taking our z value and dividing it by the product of negative 6 times 3. Now you have to make sure we multiply those first. So 2/3 divided by negative 18. Now remember, when you divide a fraction, you flip your sign to multiplication, and then you flip that second fraction. So this is actually going to become -1/27. So then we go to write our equation. Z would equal -1/27 times xy. That's our joint variation equation. And then 3, we're going to solve for z in the event that x was equal to 6 and y is equal to -4. So that is going to give us 24/27, which then will simplify to 8/9. Okay, so now moving on to the rational expressions portion of the chapter. The first thing we did was check to see if x was a solution, which means you want to find out, make sure it's not an extraneous solution. So if I were doing that for number 7, for example, I'm going to put in this -3 everywhere I see an x. And what's going to happen is you're going to end up with these undefined fractions here. And so, of course, no, -3 is not a solution. It would be considered extraneous. So for number 8, we're going to try putting in the 5. So we're going to just substitute that 5 in everywhere we see an x. So that's going to give us 10/2 equals 15/3. And then both of those simplify to 5. So yes, 5 is a valid solution for that equation. Okay, so multiplying and then dividing the rational expression. So just like we do with any other fraction, we're going to multiply across the numerators, and then we're going to multiply across the denominators, but then we want to simplify that resulting fraction, just like you would with any normal numbers. So these are all monomials. So when I multiply them, I'm just kind of multiplying my like terms. So 7 times 2 give me 14. Then I could go to my x's, and when I multiply my x's, I add those exponents. That gives me x to the 11th. And then I also have that y cubed. On the bottom, I'm going to do the same thing. So I'm going to multiply my constants. So 5 times 21, which is going to give me 105. And then I just have that single x and then a y to the 6th. So now, cat scratching at the door there. Okay, so now we want to reduce this fraction here, 14/105, just like you would reduce any other fraction. Just kind of forget about everything else and just focus on that. It reduces to 2/15. Now, some of you might have got that from the beginning if you had done some like cross-canceling with the 7 and the 21, and then just multiplied across that way, you would have got the same thing. Now, as far as the x's are concerned, we have 11 on the top and just the 1 on the bottom. So you would subtract those exponents. 11 minus 1 leaves you with 10 on the top. And then the y's, you have 6 on the bottom, 3 on the top. So I always put my answer where the bigger number was. So 6 minus 3 is 3. And so this would be my resulting simplified answer for that one. Okay, so then number 10, these are trinomials and binomials. So these are the ones you have to factor out first. You want them as simple as possible. So this numerator here is going to be the two numbers that multiply to get 10, that subtract to get 3 is 5 and -2. Then we have this monomial on the bottom, which we can't do anything with right now. Then this numerator over here, we can take out a GCF of 2, leaving us with x plus 4. And then this trinomial will get factored into x and x, and then a +4 and a +5. Now at this point, because you're multiplying here, I mean, you can kind of just get rid of your multiplication sign. Everything on the top is just going to be on the top. Anything on the bottom is on the bottom. And you just want to go ahead and cancel anything that's the same on the top and the bottom. So x plus 5, same on the top and the bottom. Remember, if you're canceling a binomial, it's the whole thing. X plus 4, you've got an entire x plus 4 on the top and the bottom, so those can both go. And then this 2 here can be canceled with this part of that monomial. So then all we're left with is x minus 2 in the numerator and just that x squared in the denominator. And that would be our simplified answer for that one. All right, so moving on to number 11. It's another multiplication problem. Same idea though, we want to do the factoring and then see what cancels. So in my numerator on the left here, x and x, the two numbers that multiply to get 6 and add to get 5 are 3 and 2, and because it's a negative 5, they're both going to be negative. On the bottom, I can take out a GCF of 5. Then on the top, on the right-hand side, factoring that, the two numbers that multiply to get 12 and add to get 7 are 3 and 4. And then on the bottom, that's one of those difference of two squares patterns. Since 9 is a perfect square, you can just do plus 3 and minus 3, and those would cancel out in the middle. That's why you don't see that middle term. Now, anything in the numerator that cancels with anything in the denominator, so we would have x minus 3. There's 1 on the top, 1 on the bottom. There is an x plus 3 on the top and the bottom. There is an x plus 4 on the top and the bottom, so they can all get canceled. Then you're left with the x minus 2 over your 5 as your final answer. Now, the next three problems are going to be division, and the only thing that's different with the division is that you have to leave the first fraction, change that sign to multiplication, and then flip that second fraction, and then you do everything the same. So for this one, I'm going to recopy it first. So 3x to the 5th, y to the 3rd over 7y squared, changing my multiplication sign there, and then 21y to the 5th is going to move to the top, and 9x to the 4th is going to move to the bottom. Now, since these are all monomials, I'm just going to multiply my fractions across the top and the bottom. If you would like to cross cancel to reduce and make those numbers a little bit simpler, so like 7 and 21, you could make it a 1 and a 3. The 3 and the 9, you could make that 1/3 as well. It might help you out a little bit with the numbers not being so big. So now 1 times 3 is 3. Then I have an x here on the top, but that's the only x I have in the numerator, so I don't have to combine it with anything. And then I have y to the 3rd and y to the 5th, giving me y to the 8th on the top. On the bottom, I have a 3, x to the 4th, and y squared. Now, of course, the 3's are going to cancel. Had you multiplied it out and had 63 over 63, it would have still canceled. Now you've got your x to the 5th and your x to the 4th. So when you subtract those exponents, you get an x on the top. And then when you do your y's, 8 minus 2 is y to the 6th, also on the top. So since there's nothing left on the bottom, you can just leave your final answer as xy to the 6th. And the next two division problems are going to be ones that we factor. So as I factor them, I'll just put my factored answers on the opposite side for that second fraction. So the first trinomial here, we factor into x and x. The numbers that multiply to get 16 and add up to get 8 are 4 and 4, both positive. My denominator here, I just have that GCF of 3 that I can take out. I'm making my sign multiplication now, and now these two I will put on the opposite side when I factor them. So the x squared plus 6 plus 8, I'm going to factor and put on the bottom. So the two numbers that multiply to get 8 that add to get 6 are positive 4 and positive 2. And then the x squared minus 4 is a difference of two squares. So it's going to be a plus 2 and a minus 2. Now I want to do my canceling. So I have an x plus 4 on the bottom, and I get to cancel one of my x plus 4s on the top. Only one of them. Doesn't matter which one, but you only get to do one. Same process for the x plus 2s. I've got two x plus 2s in my denominator, but only one on the top, so you can only cancel one with one. So everything else is still remaining. So my final answer, I have x plus 4 times x minus 2 on the top and 3 times x plus 2 on the bottom. I think I said the wrong thing when I wrote this, but as long as it looks like this. Okay, so for number 14, I'm going to factor this numerator here. So x and x, the two numbers that multiply to 14 that subtract to get 5, are positive 7 and minus 2. And then on the bottom, x and x, the two numbers that multiply to 28 that add up to 11, are positive 7 and positive 4. Changing that sign to multiplication, and now these two I'm going to put in the opposite spots when I factor. So the 3x minus 6 is just a GCF of 3, and that's going to go on the bottom. And then this trinomial here, x and x, the two numbers that multiply to 36 that subtract to get 5, are 9 and 4, and it's going to be a negative 9 and a positive 4. So now we want to do the canceling. So x plus 7, there's one on the top and the bottom, those can go. X minus 2, one on the top and the bottom. X plus 4, same thing. So now we're just left with x minus 9 over 3. Now you cannot reduce that 9 and 3 because remember the 9 is part of a binomial. The binomials have to stay as one piece. You can't cancel parts of them. It's all or nothing. Okay, so now we're going to move on to solving the rational equations. And remember, there was two methods we did for that. So you can do the cross-multiplying method if you only have two different denominators. If you have three different denominators, then you're going to have to do the LCD method. Okay, so if we take a look at number 15, for example, even though we only see two denominators, this 8's really over a 1. So that's really three different denominators. So we will have to do the LCD method there. Number 16, however, we have two of these denominators are both the same, so we don't have to do the LCD method. We can just cross multiply. If you want to do the LCD method, you can. All right, so let's do the LCD method for number 15. So when we're figuring out our least common denominator, I have a 1 and a 4 as my constants, so the bigger of those, the 4, both of them go into 4. And then I have an x here, a single x, and a single x here, so I need to have at least one x. So I'm going to distribute this 4x to every term in my equation, and that should cancel out all the fractions. So when I multiply 4x times negative 20, the 4x in the top and the bottom are going to cancel, so I'm just left with negative 20. When I multiply my 4x times the 8, there's nothing on the bottom to cancel with any of that 4x, so I just have to multiply it, and I get 32x. When I distribute my 4x to the third term, the x here will cancel with the x here, so then I just have to multiply the 4 times the 3, and I get 12. Now I would add my 12 to both sides. Add 20 to both sides. And now I'm going to divide by 32. And I'm going to get x equals 1. Now you should always check for those extraneous solutions. So if I were to check here, I would have negative 20 over, and that's going to be a 4, plus 8 equals 3 over 1. So this is really negative 5 plus 8 equals 3. Which does work, so the answer is not extraneous, it is legitimate. So now for number 16, because I can do the LCD method, which I would have to distribute x plus 1 to everything. So if I want to do it that way, just to kind of show you the options, x plus 1 is my LCD here, so I would distribute to all three. Now when I distribute to the first fraction, those cancel. I'm left with 5x. When I go to the 4, nothing cancels, so I would have 4 times parentheses x plus 1. And when I distribute to the third term, the x plus 1's cancel, I would just have the 5. So at this point, I would distribute the 4 and solve the equation just like a normal equation. So combining those like terms, subtracting the 4x, so I'd get x equals negative 1. Now, if I'm going to do this by the cross multiplying way, I would need to bring this term over to the other side, right? So then I'm going to end up with 5x over x plus 1 plus 5 over x plus 1. And the other side, the equal sign, I just have my 4. Now, because those are like terms here, when you add fractions, you just write the answer over that common denominator. Then I would cross multiply. So on one side, I have 1 times 5x plus 5. On the other side, 4 times x plus 1. This gives me 5x plus 5 equals 4x plus 4. Subtract my 4x, subtract my 5, I get x equals -1. So it doesn't matter, you're going to get the same answer either way. Now, we still have to check this to see if it's extraneous. So if I go to plug in, and I do 5 times -1 over -1 plus 1, you probably can see right away what's going to happen, that it's going to become undefined. So I have -5 over 0 equals 4 minus 5 over 0. So there is really no solution for that equation. All right, and so then the last few here, obviously for number 18, you're definitely going to just approach that with cross multiplying. It's just one fraction on either side. So x times x minus 4 on one side of the equal sign, 2 times 2x minus 6 on the other. Then you are going to distribute. Now I see that this is going to be quadratic because I have an x squared in there. So I'm moving everything to one side of my equation. So that's going to give me x squared minus 8x plus 12 equals 0. So quadratics need to be solved by having them equal to 0. Now you can factor it, or you could put that on your graphing calculator and see where it intercepts the x-axis. The two numbers that multiply to 12 that add up to 8 are 6 and 2, and they're both negative. So I'm going to have an x equals 6 and an x equals 2. Now you would have to then plug these in to see if either one of them is extraneous, but they do both work because I've already checked them. So I'm just going to move on to save some time here. Now the next problem, you could use LCD or cross multiplying. So because I have two denominators that are the same, if I just bring my 8 over x plus 4 to the other side, for me, I think that's a little bit easier because 5 minus 8 is -3, and then I'm just going to put it over that common denominator of x plus 4. Now I can cross multiply. So I have -3 times x minus 2 on one side, 10 times x plus 4 on the other. Now I'm just going to distribute to eliminate my parentheses. Add my 3x over here. So that's going to give me 13x. Subtract my 40. So that's going to be -34, I believe. And x equals -34 over 13. Now, I believe we did this exact same problem when we did the notes section, and you believe it or not, the solution does work out. It's not extraneous. So, okay, number 19. I believe that's our last one on this review today. And I'm just going to cross multiply it because we just have two simple fractions. So -2 times x plus 1. On the other side, we have x minus 1 times x minus 8. Now this one's a little bit different because we're going to have to FOIL these two binomials together. So I have -2x minus 2 on the left. And on the right, it's x squared minus 8x minus x plus 8. I'm going to move everything to the one side so that I can combine my like terms and make it equal to 0. So I have x squared. This was -9 plus the 2 is going to give me -7x, and then plus 10. Then you could do this on your graphing calculator or factor. The two numbers that multiply to 10 that add up to 7 are 5 and 2, and they're both going to be negative here. And that would mean my solutions are x equals 5 and x equals 2. Now, in this particular problem, one of these solutions is extraneous. So if you got this problem on your test, and you will get one like it, you have to make sure you're only choosing the multiple choice that has the answer that actually works. If you choose the one with both, it's going to be wrong. So if you were checking this, -2 over 5 minus 1 equals 5 minus 8 over 5 plus 1. -2 over 4 equals -3 over 6. Well, those both work out to 1/2, so that's fine. Now, when I go to check the 2, -2 over 2 minus 1, and then 2 minus 8 over 2 plus 1. So this is -2 over 1, -6 over 3. And let's see, that actually probably does work, right? Did I do something wrong there? No, we're good there too. So that one works as well. Okay, so that's it for today. If you have any questions, please just, email me or send me one on Remind, and do the best that you can on your test. Don't forget to refer to the formulas in your notes. And that's it for today. Have a great weekend.